Okay, we are going to talk a little bit about some of the transformer concepts that you have probably read through in your ILM. Um, so one of the first things is the transformer terminal markings. We're going to get into further detail about this transformer terminal markings, but for now, we got to know that when you guys see the H right here, the H's, that always refers to the high voltage side of the winding, and whenever you see the X's, that refers to the low voltage side of the winding. So the difference between the high voltage and the low voltage side of the winding is that the high voltage will always have more turns on it than the low voltage side. Okay, so that's what makes it the high voltage. High voltage has more turns and the low voltage has less turns. So if I were to put an ohm meter across here, an ohm meter, which one would give us a higher ohmic value? So if I were to use my ohm meter to determine which is, if say the terminals weren't marked, um, I should see a higher resistance across the high voltage winding because physically there's a longer length of wire, more turns, and it's usually a smaller gauge as well. And then on the low voltage, we'd have a larger gauge wire, but a lot less turns. Okay, so this is what determines the how much this transformer is going to step down. It's a difference in the number of turns on the primary to the number of turns on the secondary. So we're going to get into some of these ratios. And when we talk about the ratio of a transformer, we're going to talk about the ratio of the voltage of the primary to the voltage of the secondary. And this is going to be the exact same as the ratio of the number of turns on the primary compared to the number of turns on the secondary. And after we learn a little bit more about current, we're going to see that we're going to have a current ratio as well, which is exactly opposite our voltage ratio or our turns ratio. So the I, so it's exactly the opposite voltage primary to voltage secondary. It'll be exactly opposite when we look at the numbers, I primary to I secondary. So looking at this one, we could see that we have 138 kV primary to 13.8 kV secondary. So if we were to look at that, so it's 138 kV to 13.8, and if I were to express this in its lowest terms, kV, it would be a 10-to-1 transformer. So what that means is that every 10 volts on the primary will produce 1 volt on the secondary, 10 to 1. All right. Yeah. Well, let's go on. We'll keep working with this. I guess one other thing I want to talk about on this slide is that a transformer, in this case, if the line comes in from the supply into this transformer, we would call this the primary. And this would be called the secondary. And so this would go out to our loads. Probably it would go to some sort of an overcurrent. And from there, probably feed a panel of some kind, and that's where our loads would be connected up. So we'd further reduce it down, smaller overcurrents to individual branch circuits. But you also have step-up transformers. So in that case, it's exactly the opposite. So on a step-up transformer, that means that we would bring our source or supply into the X side, and we would step up that voltage, and this then would become our secondary. This is what would be going to some sort of an overcurrent device, more than likely, and then to panel. So this could be, for example, we could step 120 up to 240 versus the other way around. Most of our transformers are step down, and we would go step down from, say, in this case, 138 to 13.8. So let's just move ahead on a slide here and just talk about that. So the top one here, we've got an example of a step-up transformer. In a step-up transformer, our primary is the X's. So that's where the supply comes in. And our secondary is the H's. So that is our secondary voltage. So we're stepping up to 480. Now we could also use the transformer. A transformer as a step down. So in that case, our high voltage comes in on this to supply the transformer. We call that the primary. And that'd be terminated on your H's. And then we'll step it down to the secondary. And in this case, we're going to produce 240 on the secondary. So these, what is primary and secondary really depends on if it's a step up or step down. But whichever winding is the high voltage winding is labeled with H's, and whichever winding is the low voltage winding is always labeled with X's. So I'm just going to erase this screen here, erase all the ink here. So what it would be the transformer ratios here. So we can tell the ratio of this transformer by looking at the voltage on the primary to the voltage of the secondary. And then we would express it in its lowest form. So it's 120 to 480. So if I took 480 and I divide it by 120, I would get 4. So it's a 1 to 4 transformer. The second transformer is a step down. We still compare voltage primary to the voltage secondary. So in this case, it's 600 volt to 240. And if we express that in its lowest form, it would be 2.5 to 1. So I take the higher voltage and I divide it by the lower voltage. And the lower voltage will always be 1. All right, so 600 divided by 240 divided by 240 is 2.5. 240 divided by 240 is 1. So 2.5 to 1. So that's the ratio of the transformer. We are going to look at how turns ratio is the same. So I'm going to give you guys an example with that.